Okay, so evaluating the unit circle. By now, you know how to label all the radians around your unit circle. And I told you they were the special radians, but we don't really know what's so special about them. Today is where we learn that. So I need you to draw these triangles, and you're going to need to pause the video because I can't stop and wait for you. That's why it is a video. Draw these triangles. Make sure you label the angle just like I did. Notice they're right triangles. And then these are your special right triangles, right? 45, 45, 90. I'll talk while you draw. If the hypotenuse is 1, then you know your two sides are root 2 over 2. If you have a 60, 30, 90 with the 60 in the bottom left corner, that's important, and the hypotenuse is 1, then you know this side is 1/2 and this side is root 3 over 2. If you have a 30, 60, 90 with the 30 in the bottom left corner, hypotenuse is 1. Now the 1/2 is over here and the root 3 over 2 is here. I understand, and you should understand, the purple and the blue are the same triangle, but the location of that angle, it's called the reference angle, that's super important. So make sure you draw these triangles, color code them if you have the time and the ability. Then, like I said, you must know these three, technically two special triangles. Notice the hypotenuse is always 1. That's because the radius of the unit circle is always 1. So if we remember the radius is always 1, we really only have 3 numbers to keep track of, and you should write them down in this order. Because if you type these into a calculator, that would be the small number, that would be the medium-sized number, and that would be the largest of these 3 numbers. Please write them down in this order. Make sure you pause the video anytime you need to catch up. Let's practice our radians on our unit circle. So if you don't have one drawn, draw your unit circle with all the correct number of lines in the correct places. If you like to color code them like me, feel free to do so. Axes are green because yellow and blue makes green. I do fourths at yellow and sixths at blue. Once you get it done, unpause your video. Let's do the sixths first, so blues and greens. So we will jump right over the yellows, just counting by sixths. Reduce as you go. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, and back to the beginning gives me 12 6 or 2 pi. Then we'll do the fourths, so yellow and green, but the green are already done, but don't forget to tap it with your pencil. 1/4, already 2/4, 3/4, already 4/4, 5/4, 6/4 is done, 7/4, and 8/4 is done. Make sure you are practicing being able to either imagine or count out the unit circle like I have shown you. Okay, why are these the special radians? Well, look how perfectly those special triangles fit into your unit circle. The blue one has a 30-degree reference angle. It fits perfectly at pi over 6. Well, if I'm trying to find the coordinate of this point, because I already know the radian, now I need to know the coordinate, the x value is just how far left it goes, which is this length of your triangle, and the y value is how tall your triangle is. So if you have those special triangles memorized, you should know that that's 1/2, and this is root 3 over 2. So this coordinate is x comma y, root 3 over 2 comma 1/2. That same 30-degree reference angle fits perfectly here as well. It's the same triangle, but now it's over here. This is still an xy axis. So when I go to label the coordinate, I need to keep in mind negatives. What's negative when you're left and up? So it's the same measurements on the triangle, but when you're left, it's negative root 3 over 2, and up is still positive. Those same triangles happen to fit here and here also. You might notice your 30-degree reference angle fits under everything that has a denominator of 6. It's the same numbers, but you're in different quadrants. Your quadrant will change your negative signs. What would this coordinate be? Well, it's left, which is negative. We know left is negative, but it's also down. So they are both negative over here. Then I go over to this coordinate. It's to the right, which is positive, and down, which is negative. So positive root 3 over 2, comma negative 1/2. Moving on to the fourths. Look how perfectly that 45-degree reference angle fits in our unit circle at pi over 4. The measurements of your 45-degree triangle both happen to be root 2 over 2. So my xy is going to be root 2 over 2, comma root 2 over 2. Same triangle fits perfectly at the other pi over 4 location. It's left and up, So negative for your x, but positive for your y. Fits in the other two as well, as I'm sure you've guessed by now. See if you can label your last two radians. So for this moment, label these, pause your video and label those two on my screen. This corner is negative, negative. This corner is positive, negative. I'm sure by now you've guessed what's going to happen at pi over 3. Your 60-degree reference triangle fits perfectly. Those are the measurements for your 60-degree, which gives me the x and y value for pi over 3. Same triangle fits at 2 pi over 3. By now we've caught on to the negative signs. Left is negative, positive for up. It fits at my last two locations. See if you can fill in your last two coordinates for your full complete unit circle. Negative 1/2 negative root 3 over 2, and then positive 1/2 negative root 3 over 2. So this is a full unit circle, radian and coordinate at every spot. I want to say there's like 48 numbers here if you fill in the radian and the x and y coordinates. But look at my picture. If you don't have a PowerPoint in front of you, probably drawing these triangles is not helpful. So in the future, I do not recommend drawing the triangles, but logically that is how it works, and I need you to understand why these work like this. But for ease of being able to either memorize it or draw it for myself, is there an easier way? So I've already completed the radians. Notice that there's only 3 options for those small, medium, and large, right? We already know our 0, 1. We've been doing that for a while, our easy intercept points. But all the other numbers are either 1/2, root 2 over 2, or root 3 over 2. And we already talked about how they're small, medium, and large. So let's look at the x values. Let's look at one quadrant. You also probably notice they kind of repeat. There's some symmetry to the unit circle. There's negative x's here, but it's basically the same answers. And negative for both down here, and negative y over here. So if you can get quadrant 1, you're probably going to be able to just do some mirroring and some negative work to get the other 3 quadrants. But let's look at the x values over here. If I draw a line, which you don't have to draw it, you can just imagine it, this x value compared to this x value compared to this x value. Can you see which one is the small, the medium, and the large number? Clearly you can. So I know this is going to be the large x value, this one is going to be the medium x value, and this one will have my small x value. Well, I can do the same thing with the y's. Compare your y values, their heights. Maybe you're not drawing lines, maybe you're just imagining this. I can clearly see this is taller, so it's going to be my, oh, I should have gone the other way. This is shorter, this is going to be my small y value. This is the medium one, it'll be my medium y value. And this is the large one, it'll be my large y value. Well, I know my small, medium, and larges, right? Large is root 3 over 2. Small is 1/2. The mediums are the same. Small x, so the smaller of my 3 numbers, and then large y. I can do that all the way around the whole circle. I just have to be careful of the negatives. So why don't you pause your video before I keep clicking and see if you can, even if you just use the ones I've done there, which is perfectly fine, if you work on one quadrant, you should be able to fill in the rest. Carefully fill in the rest of your unit circle and then come check it with mine. Okay, so hopefully these are all the coordinates you have. Do take a minute, if you didn't already on the last slide, to pause it and copy these down extra carefully. You need a full, complete unit circle to be able to move on, and you don't want to be studying one that's wrong. So make sure you have a full, complete, perfect unit circle somewhere, especially for our next slides. How is this helpful evaluating? This is what your questions are going to be on test day. I am not going to say, draw a full unit circle on test day. I am going to ask you this tiny little question, sine of pi over 3. You need to know the unit circle in order to be able to answer these questions. And there's probably going to be, I don't know, anywhere from 3 to 10 of these little tiny questions, but they all depend on you being able to draw or imagine a perfect unit circle. So for now, how do we evaluate this? Well, I know pi over 3 has the purple triangle that fits perfectly into it, right? This should say 60, but I put a theta there. 60-degree angle in the corner. These are the measurements. This also might need a 90-degree if I was going to be perfect, but PowerPoints take a lot of work, so give me a little bit of a break. Okay, so if I'm finding sine, I know sine is opposite over adjacent. How about opposite over hypotenuse? So I know sine of pi over 3 is opposite over hypotenuse. Well, dividing by 1, the answer is just root 3 over 2. That's the answer to sine of pi over 3. I drew my triangle. I did SOHCAHTOA. Well, what about 2 bar? All right. What about cosine of pi over 3? Same triangle. So pi, adjacent over hypotenuse. So I know cosine is equal to the adjacent side over the hypotenuse. Since the hypotenuse is 1, that doesn't really matter, so the answer is 1/2. But look at pi over 3 on your unit circle, your perfect unit circle that has all the answers on it. That's where we're going for all these answers. What do you notice at pi over 3 about root 3 over 2? And what do you notice about pi over 3 about 1/2? So you should have noticed that sine is the y value that you have written on your perfect unit circle. And cosine is the x value that you have written on your perfect unit circle. And that makes sense because the adjacent side over hypotenuse, which is 1, so adjacent is your x and opposite is your y. So you should write this down. Cosine, so cosine is the x and sine is the y, but this little trick down here, it's alphabetical. If you normally write a point x comma y, x comes before y in the alphabet. Well, luckily, cosine comes before sine in the alphabet. So x is really cosine theta and y is really sine theta. This should help us answer the questions. But there's 3 trig functions, correct? So make sure you have that written down, pause it whenever you need to. What about tangent? So pi over 3 triangle again. 60 degrees fit perfectly in there. This is 90. Here's my triangle. Tangent TOA, opposite over adjacent. This is never acceptable, fractions and fractions. So I keep the top, I make it multiply, and I flip the bottom. 2 over 2 crosses out, and the answer is root 3. But annoying to have to draw the triangle each time, right? Tangent is y over x. This was the y value at pi over 3, and this was the x value at pi over 3. So tangent is also the slope of the line, which we'll talk about more later. Then you do have to do some math. Tangent is not just a glance at it and see the answer right away. You flip and make it multiply, and then you rationalize if needed. So let's do 5 pi over 6. We're not drawing pictures anymore. Are we? No, okay, good. You are looking at your unit circle. Go to 5 pi over 6. It's y over x. At 5 pi over 6, and this is why your circle needs to be perfect, put the y value over the x value as a fraction. So the y value over the x value. Then we're going to keep the top, make it multiply, and flip the bottom. Keep the top, flip, and multiply is how we usually say that. Keep that negative sign there. Reduce, cross out your 2's. But this is where the rationalize if needed comes into play. For special triangles on the unit circle, we do not leave square roots in the bottom. So to rationalize this, you're going to multiply by root 3 on top and bottom. When I multiply the top, I'm just going to get root 3, but the reason I did that is because when I multiply root 3 times root 3, now I just have a regular 3 at the bottom. So the answer to tangent is negative root 3 over 3. That's my answer box. You might have noticed this big yellow with a red box around it, line around it, box popped up. If you ever get an answer that is something, that a value just represents something over 0, the answer to tangent is then undefined. If you ever get an answer that is 0 divided by something, the answer is then 0. Jot that down if you need to. Here we go. So, Mrs. Hodge said there's going to be from 3 to 10 of these questions on the test. What exactly do I do when I see one of these questions on test day? So when I see sine of 11 pi over 6, here's what I do. I find 11 pi over 6 on my perfect unit circle. So whether it's in your head or you have to draw it on test day, you need a perfect unit circle. And then because it's sine, cosine comes before sine, so that's the y value. I look at 11 pi over 6 and I just write down the y value. Your teacher's not looking for any work here. So go ahead, find 11 pi over 6, write down the y value. The y value should be negative 1/2. That's the answer. What do we do for cosine 3 pi over 2? Find 3 pi over 2 on your perfect unit circle. Cosine is x, so write down the x value. Go ahead and do that. Look at 3 pi over 2. The x value I have written down is 0, so the answer is 0. What about tangent of pi over 4? Find pi over 4 on your perfect unit circle, but now you have to do some math, so tangent might take some work. The answer is the y value divided by the x value. Y over x, rise over run. Do the math and rationalize and reduce. You should have gotten 1. Okay, here's the tricks. Jot these down. Pause the video anytime you need to catch up. Again, x comma y is really cosine theta comma sine theta, only on the unit circle. Does that work? Tangent is really y over x. Reference angles, sometimes it's helpful to know what we talked about when we did the triangles. Every pi over 3, so whether it was 2 pi over 3, 5 pi over 3, etc., it always fit the 60-degree reference triangle. And then every pi over 4 always fit the 45-degree reference triangle. And every pi over 6 fit the 30-degree reference angle. It's just something that might be helpful in the future. One way I think about it, 3 times 60 is 180, 4 times 45 is 180, 6 times 30 is 180, so that kind of helps me memorize who goes with who. Your plane, your xy plane. First, we need to know how to label these quadrants. Just like the unit circle starts here and goes counterclockwise, quadrant 1 is here, 2 is here. We always use Roman numerals when we're labeling quadrants, 3 and 4. You need to know which quadrant is which. There is a trick to help me remember where the positive answers are. The phrase all, well, actually, I'll do what happens first and then I'll give you the phrase. They are all positive in this quadrant. Sine is positive in this quadrant. Cotangent is positive in this quadrant. And cosine is positive in this quadrant. So if I asked you a question in quadrant 3, if I asked for sine, cosine, and tangent in quadrant 3, sine would be negative, cosine would be negative, only tangent would be positive. So this is just giving you the one trig function that is positive in each quadrant. The phrase to help us memorize it is all students take calculus. The first letter helps you know all, well, that's just all. Students, S for sine, take T for tangent, calculus, C for cosine. So that'll be helpful later on, but it is something I use, so thought I'd share it with you. Here we go. Use the unit circle in front of you. You should have a perfect unit circle and see if you can answer all of these questions. I am not going to do any work. I'm just going to pop up the answers. So you need to pause your video right away, get to work on these 12 problems and see how many of them you can get right using your unit circle in front of you. Tangent ones might take some math, but the sine and cosine ones should be instant by looking at your unit circle. Pause your video. Okay, these are our answers. Notice the two that were spinning at the bottom. When you did y over x, you ended up trying to divide by 0 on this problem, and I put that yellow box on the screen a few slides ago. Anything over 0, the tangent is undefined. Here you did 0 divided by something. 0 divided by anything, the answer is 0. Hopefully you are able to get through these, and they seem pretty easy. Like I said, tangent takes some works. The over 4 are nice because the top and bottom are the same, so they're either 1 or -1. Okay, finally, going backwards. These will be questions on your test as well. We want theta. So where on the unit circle does sine equal -1/2? That's what this question is saying. Sine theta equals -1/2. Where theta on the unit circle does sine equal -1/2? So how do we do this? We use our perfect unit circle and we find any radians where the trig ratio is equal to the given. So for this problem, sine is y. Find every point on your unit circle where y is 1/2. Sorry, -1/2. So there could be more than one. Check every label on your unit circle and give me the theta where y is -1/2. There's two of them. Theta equals 7 pi over 6 should have a y of negative 1/2, and theta equals 11 pi over 6 should have a y value of negative 1/2. So again, no work, just look at your unit circle. So cosine theta equals 1/2. Cosine is the x value. Find every theta where x is 1/2 and write those thetas down. So an x of 1/2, hopefully you saw them at pi over 3 and 5 pi over 3. Tangent equals negative 1. These are a little harder because remember tangent is y over x. But since we know it equals negative 1, this one's a little easier because the y and the x need to be the same, but one of them needs to be negative. So you can think of it as the slope of the line. So you can look for a line on your paper, on your unit circle that has a slope of negative 1. The nice thing about tangent is that both ends of that line are the answer. So at 3 pi over 4 and 7 pi over 4, notice if you draw that line all the way through the circle, they end at the same spots. 3 pi over 4 ends at 7 pi over 4. So those are my two answers. See if you can do this last one on your own. Hopefully you got 4 pi over 3 and 5 pi over 3.